In this video we will talk about logistic regression. So, this can be a part of non-linear regression. There are other ways to do the non-linear regression like polynomial, multiple polynomial, square, x square, s cube, but let us see the logistic regression in this video. It is a non-linear regression and it is actually not a regression for continuous variable, it is for the classification, like classifying whether variable is in this x1 or y1 or y2, or the student will pass the exam or not pass the exams. In a linear regression, if you substitute the marks and attendance, you might be able to predict the student's performance in the final score, say 75.5 79.6, something like that, right. But in logistic regression it is not that, it is actually say the student will pass the exam or not pass the exam. So, it is a classification. So, we saw the difference between classification and regression in our previous lectures. So, basically logistic regression is a sigmoid function. Okay. What is sigmoid function is this exponential of t divided by 1 plus exponential of t. What is exponential function? This is just plotted the exponential function to just show what is exponential function. It is not needed because everybody knows that what is exponential function look like, right. So, so this will never be 0, right. So, for infinite it will be 0, but this kind of this kind of rises exponentially. So, it is exponential function. So, it is always good to make exponential steps, and we see this exponential curve in recent cases, right. You know where I am talking about. So, it's an exponential curve is possible, right. So, if you have this exponential curve in this particular formula, that is called sigmoid function. Somebody know the log odds or logit might be able to connect this. Actually, it is a inverse logic function or log odd or logit function. You know, in logit or log odd you have to consider not only the probability of getting the true value, also the non-true values, actually 1 minus probability of true. So, we do not want to go detail about logistic regressions and logit or log odds, do not worry about that. Let us try to understand how this logistic regression and what is the function and how the classification differ from regression, that is enough for this video. So, if I compute in this exponential terms, let me compute this. If I compute that for a sigmoid function applying e equal to 0, for example, let us see what is equal to 0. For 0 this value is 1, okay. For 0 this value is 1. Let me do this here. So, consider the sigmoid of 0 equal to e power 0 divided by 1 plus e power 0, 1 divided by 1 plus 1, 1 by 2 it is 0.5, the 0 will be 0.5, you know, somewhere here. So, this will be like that. Okay. This will be 0, this maximum will be 1, it will never be 1 basically. So, let me it is not so correct. So, okay. So, if I want to put that in the regression, probability of y being yes or no or probability of y being pass or fail can be given as e equal to x1, x2, x3 and b0 and e power t. It is e power t divided by 1 plus e power t plus 1. Okay. The t value is exactly what we computed in a regression formula. You see the regression like y equal to mx plus c, right. The b1 bn is a weight, x1 is the like independent variable and b0 is the interceptor. So, given a data, the model tries to fit this particular equation. Given a lot of training data, this model tries to fit into this equation. After fitting this equation, we can use this equation to predict the future training data, that simple as it is. So, do not worry how this fits into the model, that is not let us not go into detail of the logistic regression here. Instead, this is the formula there is a model which tries to fit the given data into this particular model, creates the answer for that, like what is x1 and x2 and what is the b naught, that is it. So, it is similar to the linear regression where we get a weights, weight 1, weight 2 or till weight n, and intercept value is the trained model. What is the trained model there? Y predict equal to intercept plus weight 1 x1, the weight 1 and intercepts are trained model. Similarly, in logistic regression also you will get a weights b naught, b1, b2, bn. Okay. Given that value, you can use that value to predict the future things. For example, compute the weights coefficient using the training value and use that to predict the future values. If the future value probability is greater than 0.5, you can put it as a yes, if it is less it will be 0. What is 0.5? We saw that 0.5 in a sigmoidal function is at a 0th value. The 0 can be moved, that is called the intercept is coming into picture. Okay. So, 0.5 is the value, above probability 0.5 you can group them into one particular classifier, below 0.5 can be other classifiers. You remember that we saw to compute the metrics in machine learning, we used the probability classifiers is used widely, and they are using these classifiers to predict the probability of outcome, and we can adjust the threshold of probability to improve the recall value and precision value. You plot at area under curve, right. If you remember that things, that is how this probability is used. Okay. So, you knowing what is logistic regression and linear regression. In linear regression the plot is linear, in a logistic regression the line is not linear, it is non-linear function. In the both model you give a input data, you get a trained data in form of intercept weight 1 and weight 2 in both model, but linear model fits simply into linear equation and in logistic regression it fits into a sigmoid function, that is a difference. But what is the other difference between linear regression and logistic regression? Can you list down? After listing it down, listen to the video to continue. So, it is simple, it is a continuous versus categorical data. In linear regression it is a continuous and it is a categorical yes or no, pass or fail or multiple classes, not just two classes, binomial or more. Okay. Do not think logistic regression will be only two classes, there are multiple ways to do the multi-class classification. And linear regression is easy to interpret. Okay. It is just a line, you can say this is the weight of this particular value. It means keeping this all other variables constants, the x1 as x1 is dependent on y1 in this particular scale. But in logistic regression also it is very easy because it also gives you the weight 1, weight 2, but it varies based on the functions you use, the train function you use, but it is also easy, it is not tough. And error minimizing method in a linear regression we saw is least mean square error, right. We saw the difference between predicted value and actual value is used to predict the best objective function, but in logistic regression it uses ML method, maximum likelihood method to do that. So, that is the difference. So, we are not dealing with the training of a logistic regression in this video. Okay. So, in this video we introduced what is logistic regression, that is the purpose of this course. We do not want to go detail of logistic regression. Again, if you want to know more about logistic regression, please go and watch Introduction to Machine Learning by Professor Andrew Yanshi, videos available freely in YouTube. He explains it very good. Also remember that most of the data science or data prediction happens today by using logistic regression. Although we have very sophisticated softwares or sophisticated classifiers or deep learning for better image classification or voice recognition, in a basic data or classification of fraud detection or spam or anti-spam or a lot of other things, logistic regression is used. Thanks for watching this video. Thank you.